Hi. Yeah. Today I'm going to talk about the importance of physics. So why we have to study the physics, and I mean, what are the basic that we need to know to learn physics more deeply. And I'm going to teach this the basic physics class for only more than higher school students. uh, the physics is you should understand that the physics itself is a the basic understand. So what how do you define the motion? The motion is basically so which we call actually relative motion. So what is relative motion? So relative motion is like when you talk about the motion of object with respect to bus, or motion of bus with respect to the person who is standing at rest. So these are all relative concepts. So if you would like to differentiate the motion of, like, if you can also differentiate motion of object with respect earth to the other planets. You can also talk about the motion of earth with respect to sun, moon, etc. So all this comes under the physics phenomenon. So this is the one part of the physics. Basically, you talk about the motion, you talk about the physics stands in the daily day to day activity. Coming to the other side of the physics is like electricity, magnetism, uh, and the if you want to go deeply higher standards like modern physics, nuclear physics, molecular physics, atomic physics, etc. Quantum physics, classical physics, relativistic physics. I mean, what are all these things? The physics is such a subject you love it. If you understand the physics, I mean, you love it like anything. First thing, suppose let me talk about few example that I would like to bring attention to you. I mean, the motivation. You can think about this is kind of motivation. I mean, the first thing, very basic stuff I would like to explain. So you know the atom, right? Yes, the atom has some particles. I mean, you guys know that electron, neutron, protons. All these three particles exist in the atom. I mean, what are these actually? These are the charged particle. Are they charged particle or neutral particle? I mean, you know that electron and proton are the charged particle, whereas neutron is a neutral particle. But what they do actually, I mean, how they exist in the atom. I mean, you know that the electron always revolving around the nucleus in a particular orbit, and whereas proton exists in the nucleus. So let me talk about this particle first. What is electron? It is a charged particle. It has a negative charge. We always talk about the motion of charge is called current, right? I mean, when the charge is moving with respect to time, there is a current. Q is equal IT, I is equal Q by T. So dq by dt. It's a rate of change of charge. I mean, these electron carry, I mean, flowing, moving around the nucleus, which means it is moving around the nucleus with respect to time in a circular orbit. So you can think about something is going on here. It's not it's not a rest particle. It is moving. When it's moving, definitely it carries a current, and not only current, it also create the magnetic field, right? I mean, so it so you need to understand that whenever any charged particle moving with respect to time, then it has both electric field as well as magnetic field. So then, okay, so then we go for the proton. So proton is a positively charged particle. I mean, what is the, I mean, you can ask me what is the positive charge. I mean, it's just completely with, it's again relative concept. When I say the charge of electron is a negative, which is minus 1.6 into 10 to the power of minus 19 coulombs. With respect to this electron charge, quite opposite charge for the proton. So proton has a positively charged particle. I mean, exactly same amount of the magnitude of the charge is same for both electron and proton. So here you have to understand concept. I mean, let me talk about the briefly about neutron too. So neutron is a particle which has a neutral. Which what is meaning of neutral? Because it doesn't have any charge. It doesn't reflect to the any field. Even if it suppose if you allow this particle through electric and magnetic field, it doesn't reflect. It doesn't deflect also. It doesn't even feel anything, which means it just doesn't care any field. Which we call neutral particle. I mean, you can ask me, does it have a uh, magnitude of? Does it have anything? No, it doesn't have any charge. It has a mass, of course. It has a mass. Electron has a mass. Proton has a mass. Neutron has a mass. Now the question is, let me ask the question. We all know that any moving object loses its energy, right? But here, the electron revolving around the uh, nucleus forever without losing its energy. I mean, what is causing here? What is causing here? Why electron doesn't lose energy? And if it loses, let us assume that if electron loses its energy while revolving around the nucleus, if it loses, it should, what happen, students? It should collapse into the nucleus. Of course, right? If I ask you someone to move from here to 2 kilometers, and if I ask them to come back here, definitely what happen? They will become so tired. They lose energy. If I ask you to make for 10 rounds around this your area of your building, of your classroom, of your ground, definitely what happen? They loses their energy. But in the case of electron, doesn't lose energy. So what is going on here? What principle involved here? I mean, you know that you guys already studied in the school level, and according to the Bohr postulate, the electron revolving around the nucleus in a particular orbit, station, we call it stationary orbits, right? And the here you should know, you should understand that its angular momentum is conserved. What is that? Angular momentum is a concept you might have understood, you might have studied in the motion. And you might have studied this in the rotational motion. So angular momentum, I mean, you have studied a torque. Torque is a rate of change of angular momentum. Angular momentum is MVR, MV cross R. So whenever the object is rotating around its fixed axis, it has a angular momentum. So when we talk about the linear motion, we have talked already about the rotational motion. Linear motion, we don't talk about this fixed axis. So the motion which move in one direction, we call it linear motion. The motion around a in a fixed axis, we call it as a rotational motion. So whenever you talk about the rotation motion, you have the angular momentum. That's correct. So L is equal to mvr. So in this case, the angular momentum is constant. It doesn't change its angular momentum, which means the angular momentum is conserved. What happens if the angular momentum is conserved? The angular momentum, when the angular momentum is conserved, so you should know that energy also conserved. How? I mean, definitely L square by 2I, right? So energy must be equals to L square by 2I. Here L is angular momentum, I is a moment of inertia. And these two inside the bit, it require energy. Once it enter into the orbit, or it doesn't lose energy. It just keep on rotating around that specified route. So here electron doesn't lose energy. It always, moving around the nucleus in a stationary orbit without losing its energy. So it doesn't collapse into the nucleus. Right. So you understood now nucleus. But I have one more question, interesting one. You know that nucleus has two particles, right? One is proton, the other one is neutron. My question is, in general, to annihilate or to together or to bind together, so definitely it requires some amount of binding energy. Here we talk about proton and neutron. We know that proton is a positively charged particle, while neutron is a neutral particle. My question is how these two particles together in the nucleus, even though they have they have one is charged particle, the other one is neutral particle. I mean, they don't have, there is no electrostatic force between them since they are not a charged particle, right? So, but what is making them? What kind of force? What kind of force acting between them which makes them bind together? Does anyone answer it? I mean, we know that there is only one and only force, which is the strongest force in the universe. What is the force? Yes, it is a nuclear force. Nuclear force is the one which bind these two particles together. I mean, you have the nuclear spin. We're going to talk about this, higher classes, but nuclear force is the one which bind them together. Right. So now we learn about this. Right. So now we talk about the atom and how the electron revolving around the nucleus and how what is going on this thing. So now I want to focus little more actually. I want to focus further. So next few minutes I'm going to talk about the atomic levels. I mean, what is there actually? What is the matter actually? What matter has actually? So you know that matter is basically, consists of atoms. I mean, what are the types of matter? You know that, right? How many types of matter? Anybody knows? Yes, three? No, we have more. I mean, I mentioned before, right? Yes, solid state, liquid state, gaseous state. There is one more state called plasma state. Yes, in every state, the atoms are arranged in a regular manner. But what is going on actually? If you want to know materials, you must understand the atomic levels, atomic structure. You'd like to, let's say, You want to know the purity of material like gold, platinum, silver, any metal, copper, any metal, aluminum. You must understand the atomic structure, atomic levels, arrangement of atoms in the crystal. Yes, that is very important. So now the question is how the atoms arrange in the matter. Every matter, you know that solid state. Again, there are two types: crystalline solids, non-crystalline solids. Crystalline solid, you can think about it. Amorphous solids. See, the solids itself, crystalline solids, semi-crystalline solids, amorphous. What are these? Definitely must know this because in future you're gonna be material scientist. You must understand the atomic level, how the atoms arrange in a particular manner. To understand that, regular, like in the it's all atoms are arranged in a well manner, like means periodic manner, like one by one. So the arrangement of atoms in a regular manner, we call it as a crystalline solids. Whereas if the arrangement of atoms in a random manners, they don't have a particular manner arrangements. So there we talk about amorphous crystals, amorphous solids. So here you don't talk about the particular unit cell, you don't talk about the arrangement of atom in a particular order. It's tough to determine the structure here. And the other one is semi-crystalline solids. Here the part of the solid, the part of the crystal arranged in a crystal manner, the part of the crystal is amorphous. Like random, you can it's kind of semi-crystalline solids, right? I mean, why do we need this? Definitely, you as a material scientist, as a scientist, you should know the purity checking. You should know what when you apply when you give the external energy to these atoms, they behave differently. Like if you have a material highly orders, like crystalline manner, that's such material is very good for in terms of like mechanical properties, thermal properties, electrical property. What are those things? Definitely should know that. As we all know that we use the material for day-to-day life. We use the gold, we use the silver, we use the aluminum, we use the many material. You must know what are their properties, what temperature it holds. Like aluminum, we use it, right? Micro oven. Like what what is the temperature that it sustain in the micro oven? What is actually micro oven? So let me talk about micro oven briefly. It's a very interesting question. Sometime it's gonna ask various competitive exams. Does anybody knows micro oven? The micro oven is the one which helps to cook the food very fast. What is that? I mean, what is making? How it generated in the micro oven? No, everybody says also no, sir. We are applying the current. It just helps to cook the food. No, that's wrong also. We all know that micro oven as there is a one device which produce the micro, right? So yes, micro oven means it has a microwaves, but we all know that microwaves, right? We ultra waves, microwaves, right? IR rays. You should know, you should have idea of this microwaves. So what are those microwaves? So microwaves basically can produce some sort of energy. I mean, they have some wavelength, definitely. They have some specific frequency, etc. But how come it produce heat? Yeah, question. Does anybody knows? Yes, here the situation you need to understand. Whatever food you keep in the microwave, every food has a water molecule, right? The water molecules has its own frequency. What is frequency? Whenever the material, the food, or whatever object has a frequency, means it vibrates it from its mean position, right? Here the water molecules, H2O, right? O, there are two more. HO, right? Its angle, you guys know, 109 point something. It has a own frequency. It vibrates from its mean position. Now, now here you should understand the frequency of microwaves matches with the frequency of the water molecules. When it's happen, when this matches, when this matches, there is a phenomenon called resonance, which produce the heat. So this heat can help the cook food easily. I mean, you must understand what is the principle involved in micro oven which could help to cook the food easily or fast. You should answer it. It's due to the resonance principle. I mean, what is the resonance here? Just simply the frequency of the water molecule matches with the frequency of microwaves. When this is happen, you could see the resonance, which could help the to produce more heat in a shorter time. Right? I mean, this is very interesting. Then we're gonna study more things in the next class. Okay, okay, students. Thank you. Will I mean, I'll have another class on more on the modern physics, like what is actually all this postulate we learn, Bohr, Einstein, Thomson, all this sort of so basically dual nature of radiation. So we're gonna talk about more in that lesson next, and then so later on, like we'll go for the semiconductors, waves, electromagnetic waves, induction, etc. Thank you.